Okay guys, so yesterday we looked at solving inequalities. Today we're going to be graphing inequalities. You should be able to understand what I mean by that by the end of this video. And you should also know how to solve quadratic inequalities using graphing. Technically you can do it without, but I would highly recommend doing it anyway so that you never make a very common mistake that students make year after year. So let's start with this question. By showing these three inequalities, find the region of all three of them. Okay, so whenever we have inequalities, you can plot them as if this is an equal sign, right? Yeah? So x is less than or equal to 6. What's that going to look like on the graph? Well, x is here, so our graph is going to look something like this. Yeah? Y is greater than or equal to 2. That's going to look something like what? Y is here. So let's put it here. Y is greater than or equal to 2. And then finally, y is less than x plus 1. Well, we can rearrange that. So y, wait no, that's already in the form y equals mx plus c. Let me write that down. Y is equal to mx plus c. And we were told in the previous class how we can write that down. So we got our xy's. We got 0, 1, and 2. Y is equal to, we sub in 0, we get 1. We sub in 1, we get 2. We sub in 2, we get 3. 1, 2, and 3. And then we put a line through those and every subsequent point to it. Now what we need to do is we need to apply the inequalities. So, x is less than 6. So this means all of this region, right? Yeah? Y is less than 2. So it's greater than 2. And because it's greater than 2, it's everything on this region. And finally, y is less than x plus 1, which is everything in this region. So we can clearly see that the region that we're after goes through this triangle, so we can label this region a really bad R. Actually, let me make that a bit better. And then I'll color it in. And so this region is R. A very bad R, but this is R. But Sammy, you can't really see, like in the exam, I'm going to have a pencil. How on earth am I going to show the examiner that I know that this is the point? Well, this is where an alternative method comes in. We do the same thing as we last did, right? So we got x is greater than or equal to 5. That's something like this. Right? Y is less than 4. That's something like this. X plus y is less than 6. We need to put it in the form y equals mx plus c. So y is less than minus x plus 6. Now, this is important. Notice the sign here. This is not inclusive, which means it's going to be a dotted line. I'll show you what I mean by that in a second, but first let's plot it. So x is 1, 2, 3. Y is, okay, when we put y in minus x, that's going to be 5, 4, and 3. So let's put those points. 1, 5, 2, 4, 5, 3. And this time we're going to put a dotted line between them to show that the examiner that we know that it's not inclusive to the line. It's only what's greater than the line. Does that make sense? So this is a solid line because it could be on the line because it's or equal to. But in this one, no. It's strictly greater than. So now what we're going to do is, you saw last time this abomination that we have sketched. We're going to do the opposite of what it's telling us to, right? So x is greater than or equal to 5. We're going to put it as such because this is less than. So we're just going to say, all right, this is greater than. So it's not here, right? It's not here. It can't be here, right? Y is less than 4. I'm going to plot what it is when it's greater than 4. Because guess what? It's not here. Right? And then finally, y is greater than minus x plus 6. Well, I'm going to post y is less than minus x plus 6. Yeah, round here. And so we can see clear as day, this is region R. Because we've eliminated where it couldn't be, which is the opposite of these inequalities. So therefore R is bang in the middle there. We might also be asked to do this and reverse engineer it, right? The shaded region in the diagram is bounded by 3 lines. What is the 3 inequalities of the shaded region? Well, first things first, let's figure out what the equations of said lines are. I'll call this L1, I'll call this L2. Let's do L2 first, it's just easy. This is minus 1, so therefore this is x is equal to minus 1. This one is a little bit trickier, but let's take a look. You can see it goes through 4, 0, and it also goes through 0, 4. The grad is equal to the change in y over change in x, which is 4 minus 0 over 0 minus 4, which is obviously going to be equal to minus 1. And because it goes through 0, 4, y is equal to minus x plus 4. Now that we have the lines, we need to figure out the regions. Now, notice these arrows. This arrow here and this arrow here. This is emphasizing that y and x are getting bigger. So if the region is towards these arrows, it's going to be greater than. So, okay, 0. Is 0, or specifically x being equal to 0, greater than or less than minus 1? It's obviously going to be greater than. But also, notice the line. The line is solid. So our first inequality is x is greater than or equal to minus 1. That's our first one. It works the exact same for y. Here, you can see that this line, y equals a third x minus 2, goes through minus 2. Is 0, or more specifically, y being equal to 0, greater than or less than minus 2? It's greater than. And more specifically, this is a solid line. So y is greater than or equal to a third x minus 2. And again, third question. We know that this line, y equals minus x plus 4, goes through 0, 4. is 0, or more specifically, y being equal to 0, less than or greater than 4? It's less than 4. And again, this line is solid, so y is less than or equal to, because it's underneath, it's less than minus x plus 4. And that will score you your marks that you are after. Now, how can we use that to solve a quadratic? So here we have x squared plus 2x is greater than 6x plus 5. How do we solve this? Well, we solve it like a normal quadratic. So first and foremost, make it equal 0. So how are we going to do that? We're going to put all of that on the other side. So we're left with x squared. 2x minus 6x is minus 4x. Plus 5 is equal to, well, sorry, no, is greater than 0. So now let's think of two numbers that add to make minus 4, but multiply to make 5. Two numbers that add to make minus 4, but multiply to make 5. Oh, sorry, it's minus 5. Excuse me. I think those two numbers are 1 and minus 5. So let's put that in. X minus 5 and x plus 1 is less than 0. And so we know that the roots, right? The roots are x is equal to 5 and x is minus 1. However, we cannot leave our answers like this because it's an inequality. So it could either be, our solutions could either be x is less than 5. Sorry. Our solutions could either be x is less than minus 1, x is greater than 5. Sorry, this is minus 1. Or it could be the way that you're more familiar with, which is minus 1 is less than, is greater than x, which is also greater than 5. Sorry, I'm getting mixed up with the solutions here, but do you understand? It could be in one of these two forms. Which one? Well, it depends on which side this thing is looking at. It depends on which side these crocodile signs, as I like to call them, are looking at. In this case in particular. I can never remember which one. I've been told thousands, I've taught this topic so many times, I can still never remember. But what I can remember is what a quadratic looks like and how the inequalities work. So what we're going to do is we're going to sketch the diagram. So what do we have? We have minus 1. We have 5. So our graph is going to look something along those lines, give or take. Right? So now what we'll do is we'll sub in a value, right? Because we know this is less than 0, right? Let's look at a point on this graph. More specifically 0, 0. If we sub in 0, 0, right, in here, then what we're left with is 0 minus 5 times 1 minus 5, 0 plus 1 is equal to what? Minus 5, right? Is minus 5 greater than 0? No, it isn't. It's not less than 0. And so therefore 0, 0 is not in the region. So therefore the region is outside. And so therefore x is less than minus 1 and x is greater than 5. If it's within the region, it would be the other way around. But it's not. It's outside the region specifically. And so we have to leave our answer like this. And I know what you're thinking, but Sammy, can't you just memorize it? Oh, if it points to x, it's out. If 0, it's in. Yes, if you can memorize that, fine. But I can never memorize it. And so many students, like if this is a 4-mark question, 80% of students are going to get 3 marks. Because they forget. It's quite hard to remember. Yes, this is a dotted line, by the way. But the whole point is just sketch the diagram and then you'll never make the mistake of realizing which one it could be. Right, thank you guys for watching this video. I hope it made sense. If you guys liked it, then please subscribe. It means the world to me. If you have any further questions or comments, join my Discord server. And if you need some extra tutoring, please drop me an email and we can organize a quote and a free meeting. Keep on learning, as you have no idea what you're capable of doing. And scene.